Before we get started with example 5, I want to show you a couple things on the graphing calculator so you have an idea of what we're going to be doing. What we're going to be doing is looking at the leading coefficient, that a value. So if you look at, we're looking at the number in front of the x squared, and that's what we're going to be comparing when we're looking at our graphs. So let's talk a little bit about that on the graphing calculator first. You don't have to do it on your own, just kind of watch along and see what happens. When I have my regular y equals x squared graph, and I go ahead and graph that on my graph, here's what it looks like. And then we're going to look and see what happens when we start changing that a value. So if I go back to my y equals, and let's put an a value that's smaller than 1 in there. So I'm going to do 0.2 times x squared. So notice it's a small number, close to 0. If I graph that, now this first one here, this is my original x squared graph. And look what happens to my graph as I get a smaller than 1 number, so 0.2. It's widening my graph, so it's going to look pretty wide. If I continue to go down, so maybe let's put on 0.1 x squared. Oops. And if I graph that, you can see, again, as I get smaller or closer to 0, my graph is getting wider. Okay, so now let's go the other way. So if I go back to my y equals, I'm going to take off these with my numbers that are less than 0. And now let's put in something like 3x squared. So now I'm getting my a value bigger than 1. And if I go ahead and graph that, if you see I have, here's my original, this outside one, and now 3x squared. Now my graph is getting skinnier or narrower as it comes up. And it will continue to do that. So if I do something like 6x squared, so again a bigger graph than that, we should be able to see that it's going to show up, right inside there. So it's even narrower than that 3x squared. So basically what's happening is when that a value, the number in front of x squared, when that number is bigger than 1, and the bigger it gets, the more narrow our graph gets. And when that number was smaller than 1, then it's going to get wider, okay? Now if I put a negative on there, the same thing's going to happen, but just in a negative way. So it's just going to be opening down instead of opening up. So if I throw in a negative 3x squared here, oops, let's go back and fix this. So you can see, oops, sorry about that. Let's go back and delete that. So opening upside down is the same concept. Instead of opening up, opening down, it does the same thing. So here's my original x squared on the outside and my negative 3x squared. The 3 is what we're worried about. The negative just tells me whether it's opening up or down. Okay, so let's go ahead and start looking at what we need. So I have example 5, and I have these 4 graphs. And what I'm looking at is the number in front of the x squared, the a, the b, the c, and d. The first question I have is for each coefficient, choose whether it is positive or negative. So if I look at coefficient a, which is this graph, is the coefficient in front positive or negative? Since this graph is opening upside down, we can say that a has to be negative. If we look at letter b, so this coefficient, again, this graph is opening upside down, which tells us that this b value has to be negative as well. Then if we take a look at c, this coefficient, now our graph is opening up. Since it's opening up, that means c has to be positive. And then if we take a look at d, that's this graph here, and again it's opening up, which tells us that d is a positive number. The next thing we want is to choose the coefficient that is closest to 0. Now remember from what I was showing you on the calculator, the more narrow it is, the bigger that number in front is, and the wider our graph is, the closer to 0 it is. And it doesn't matter whether it's upside down or right side up. Okay, we're not worried about the negative part of it. We're just worrying about which one's going to be closer to 0, whether negative or positive. And that's going to be the widest graph. So this graph is the widest, which tells us that D is going to be the one that is closest to 0. And then my last one choose the coefficient with the least value, so the smallest number. Well, your negative numbers are going to be your smaller numbers, so that means we're going to choose between A and B. And remember, the number in front of that x squared, the narrower it is, the bigger the actual number is. But now if we put a negative in front of it, that's going to make it smaller. So the narrower negative numbers are going to be the ones that have the least value. So A would be the choice here. If you have any questions, let me know.